The Earth is around 4.6 billion years old. That's 4600,000,000 years. That's such a huge number that it's difficult to appreciate how long that really is. If we think about that in terms of a single 24-hour day, then the moon was formed at about 7 minutes past midnight. That's about 23 million years after the Earth was formed. Until about 3 a.m., or 550 million years after the Earth formed, the Earth and Moon continued to be bombarded by the remains from formation of the solar system. That meant that there wasn't much chance for life to get a start. It wasn't until 4:30 a.m. that we see the earliest evidence for life on Earth, and it's not until 5:38 that we actually have any good fossils, and even these are microscopic. Sometime around dawn, life started to produce enough oxygen from photosynthesis that oxygen started to become important in the atmosphere. Then not a lot happened for more than 1 billion years, well, apart from the advent of sexual reproduction, which is thought to have started at around 20 to 6, not long before tea time. The real excitement doesn't happen until gone 9 p.m, when the Cambrian explosion led to an extraordinary increase in the diversity of life on Earth, and the development of hard skeletons which makes them much easier to find. Land plants didn't appear until not long before bedtime at around 9:30 p.m, followed a little later by land animals which likely fancied eating those plants. Dinosaurs may have had 164 million years on the planet, but on this timescale that's a little under an hour, with their extinction happening just 20 minutes before midnight. The first hominins, the early ancestors of humans, arrived late to the party with just 38 seconds to go, whilst the whole of human civilization, the Romans, the pyramids, right back to the oldest known Homo sapiens, takes just to 3.5 seconds before midnight. Geologists like to divide time into packages, based on similar sorts of rocks and, once they exist, fossils, which are formed at the different times. Some you might have heard of, like the Jurassic and the Cretaceous. As so much happens in more recent times, at least as far as we can tell, more on that later, we've ended up with more divisions in the later part of our clock, with the Cenozoic, Mesozoic and Paleozoic taking up less time combined than some you might not know so well, like the Proterozoic, Archean and Hadean individually. The rock cycle is a fairly simple scheme, but it may seem rather complicated because of the variety of routes rock materials can take to be transformed. Many of these stages, such as the formation of metamorphic rock, can take vast amounts of time. Other rock-forming processes, like the eruption of a volcano, can form new rock almost instantaneously. This brings us to an important point, the vast amount of time that some geological processes can take. The amount of time taken for whole mountain ranges to be eroded flat is almost unimaginable, but the evidence from the rock record of sedimentary rocks that are made up of bits of that mountain range and of the metamorphic roots that those mountains found at the surface shows it must have happened. And more than that, the evidence suggests it's happened time and time again, with material repeatedly moved around the rock cycle. That's possible because although some of these processes take a really long time, the Earth is so old that it's possible for it to have happened over and over again.